The next question here is an assignment question. Like, automobile manufacturer is concerned about possible recall of its best selling four-door of sedan. So if there were a recall, there is 0.25 probability that a defect is in the brake system, 0.18 in transmission, 0.17 in the fuel system, and 0.4 in some other areas. So the question here is, what is the probability that the defect is in the brakes or the fueling system? If the probability of defect in both systems simultaneously is 0.15, and the B part of the question is, what is the probability that there are no defects in either the brakes or the fueling system? So let's solve this. So let P of A be the probability of defects in the brake, and P of B be the probability of defects in the fueling systems. So the probabilities given from the question, P of A, which is the probability of defects in the brake, is 0.25, is equals to 0.25, and probability of defects in the fueling system is given as 0.17. So A part of the question is stating that what is the probability that the defect is in the brake or the fueling system. So in probability, the logics in a statement like O is plus and is multiplication. This logic is very important to go with in statistics. So now question A, or the A part of the question 7, is stating that we should determine the probability of A or B. That's A union B. But here we have been given an intersection that's between the braking system and the fueling system. There's a defect which has been given as a probability of 0.15. So now automatically, if you are having an event that intersects, that is for dependent events, P of A union B is equals to P of A plus P of B minus the intersection between the two events, that is P of A intersection B. So in this case, P of A is equals to 0.25 and P of B is equals to 0.17 minus their intersection, P of A intersection B, 0.15. So this one will now be equals to 0.27, and that's that. So if you want to prove if this really right or wrong,